So let us now talk about tests on residual outliers. Tests on residual outliers will follow the same mechanics as with the test on observation outliers that we discussed before the adjustment. The difference here is basically that we are going to have now the mean value of the population is known. So why we know that? Well, the expected value of the residuals is 0. What we are going to have to decide is whether we know the a priori variance factor or we don't know the a priori variance factor, in which case we're going to use the a posteriori variance factor. What is the null hypothesis? Null hypothesis is that the residual is normal with 0 mean, because residuals should be equal to 0, and with the standard deviation that is given by the covariance matrix of the residuals. If we are in the case when a posteriori variance factor is used, we are using the scaled covariance matrix of the residuals. The statistic is the standardized residual, which is the residual as given by the covariance matrix divided either by the standard deviation of the covariance matrix CR or the standard deviation as given by the scaled covariance matrix. Okay, we are going to have the PDF to define. This is going to be a two-tailed test. We can define the use a normal distribution or a tau distribution. So here we have the statistical statement, and you should see here that we are testing the estimated residual, not the standardized residual, but the standardized residual is here. Okay, this quantity here is the sigma, the standard deviation of the covariance matrix that is not scaled, or the covariance matrix of the standard deviation of the covariance matrix that was scaled. Okay. And we always use the tau test. We don't use student t in this case. A similar procedure can be used to test misclosure outliers. The population, the mean of the misclosures is also equals to 0. We have only two situations of whether we know or don't know the a priori variance factor. We also are looking at a time series of misclosures that is follow normal distribution. We use standardized misclosures. We are going to use now the normal distribution if we know the a priori variance factor, or we're going to use either the tau or the t distribution if we don't know the a priori variance factor. So here we have the statistical statement. It's a two-tailed test. How do you know when to use the tau distribution or the student t distribution? It is if a w prime and the sigma hat prime, if they're used from a different sample, okay, different sample, not the one that is tested, we use t. If we are using the quantity that is from the sample, we use tau. So here is just a summary of what we have mentioned. Table 13.1 the mean value, population mean is always known, and this is for the residuals. We have the situation where the a priori variance factor is known, a priori variance factor is not known. These two equations are basically the same. The difference is here. Okay, if we are going to use the covariance, the standard deviation from the covariance matrix, or of the residuals, or if you're going to use this standard deviation that comes from the scaled covariance matrix. This test, like when we talked about the observation outliers, we also can do the in-context test. Okay, and the procedure is the same. We basically will use a different alpha at the significance level. Okay, so A is the significance level of the in context. In context, alpha is the significance level of the out of context.